But if anybody's going to watch it, it's going to be him. Because there's definitely nobody else who's going to watch it, for sure. Lincoln, are you watching the video? Probably not. But if you are, hi.
Say so.
All right. Yeah, say so right now.
No.
Actually, we might have him watch it. Maybe he will be required to watch it. I think he probably will be. Because on Thursday or whatever. Okay.
He's like line, down on the line, everyone baseline. He ran.
All right. Confidence interval. Are you ready for me? Okay. Are you for real? Are you for real ready? Okay. A confidence interval is an estimate.
You're supposed to wait until she writes it.
Is an estimate for a population based on a sample. So, have you ever heard on the news or something where they're the chances, whatever, this candidate when the results come in is going to be at 52% plus or minus 5%. They're kind of at a window of maybe it's here or here. That's what a confidence interval is. Confidence interval looks like this. Kind of looks like a TIE fighter from Star Wars with and the point estimate is the number in the middle. Sometimes it's a mean. Sometimes it's a proportion. Sometimes it's a standard deviation, but for the AP test, I'm only going to be teaching you 6-1, 6-2, 6-3, and 6-4. No, just 6-1 through 6-3, because we don't do confidence intervals for standard deviation or variance. Level of confidence is how confident you are that the real mean is in that interval. Okay, so let me help you understand. If I said, what percent of the kids in this school are wearing black today? Okay, so when I say what percent of kids at school are wearing black today, I mean any kind of black on their clothing or their shoes. I would say, I don't know, maybe 60%. Maybe 60% are. Now, if I said, I bet it's somewhere between 55 and 65%. This is my confidence interval. You kind of getting that this is a confidence interval? I'm saying that I'm guessing that if I talk to the whole school and I looked at absolutely everybody, the population of the whole school, my percentage would be somewhere in there. And you'd say, well, how confident are you about that? Okay, maybe I'm 50% confident that it's in there. Now, if I wanted to be 90% confident it's in there, do you think that this confidence interval would get bigger? Or do you think it gets smaller? Smaller? Bigger. Okay, so you're saying that if instead I said, look, it's probably somewhere between, I'm still going to keep 60% in the middle. I bet it's somewhere between 30% and 90% of the kids, somewhere in there. I'm 90% confident that the real mean is somewhere, or the real percentage is somewhere in there. Does it make sense to you that the bigger it is, the more confident you are, because it's more choices? Mm-hmm. It's a wider range. Everybody okay with this? Okay. So we're going to find the critical values for a level of confidence of 95%. For this, I want you to draw a little bell curve. You're going to need your A16 page, this one. Do you remember when we were doing finding z-scores and stuff? Sometimes it would be like, what if this amount was in the middle and it was like symmetric on either side? They were preparing you to be able to do this. So let's say 95% was in the middle. What percent is on either tail? 2.5%. So what you're going to look up right now is 2.5%. So 0.025. And it should be in the middle of the table, because the middle of the table is where the area is.
Would it be positive and negative?
Mm-hmm.
Okay. So there's
So look up 0.025. Did you get negative 1.96? By the way, if you looked up right now 97.5%, because that would be 95% plus 2.5% over here, it'd be positive 1.96. So that's the critical values. All right, the margin of error formula is z sub c times sigma over the square root of n. And the critical values we just find, that's that z sub c. That's a z-score that is a critical value. The sub c just tells you that that's what we're talking about.
What does it mean?
It means what does z sub c mean? E, error. What that's going to be is once we do our confidence interval, we'll have that middle number, right? And then we're going to add the error to one side and subtract the error from the other side. So it'll be somewhere in here and here. All right, what do you think the average number of hours a grocery store employee works? Wait.
8. A day?
A week. Average.
36.
It is... Where is it?
36.
Use the data in example 1.
But it's also got counting like 8.
29.6. So we got all those part-time employees too, right?
I don't think
Assume the population standard deviation is 7.9 hours. Find the margin of error for the mean number of hours worked by all grocery store employees. Use a 95 level of confidence. All right. So because it's a 95 level of confidence, we can say z sub c is going to be 1.96. We're using the positive one. 1.96 we found just in example 1, right? Mm-hmm. So I'm going to take the standard deviation, which is 7.9. Basically following this formula right here. Multiply that by 1.96. And I'm going to divide by the square root of n. And this one, which I should have written in this problem, is, I think it was 40. 40 employees. So that is just something I missed telling you in this problem, but it would be in the book. All right, so in your calculator, take 1.96 times 7.9 divided by the square root of 40. Yep, 2.45 hours. Okay. And then if I was going to make that's how you find the margin of error. But if I was going to make a confidence interval right now, I would do it like this. I'd draw a line like this, so should you. I'd say my sample mean goes in the middle, that's 29.6. And then I would add 2.45 to one side for 32.05. And I would subtract it from the other side. What were you saying, Riley?
I was going to say we really don't need the mean, but we do actually. Just to make this, but otherwise we don't need it.
Right. So then you would say, if I was looking at all grocery store employees, so this is just like a sample, right? Like you asked 40 people and their average was 29.6. And then I said, okay, so if I was looking at all the grocery store employees, I'm 95% confident that it's somewhere between here and here. Okay. Page 2. So I'm going to start making these. They're called T-charts. I think I did it maybe once for you guys with standard deviation, where it was like one side is directions and one side is remember to do this. Okay, so the first thing you need to do is you need to verify that you know sigma. Verify that you know sigma and that it's normal, or your n is greater than or equal to 30. Because remember, if it's greater than or equal to 30, we can assume that it will be normal after the central limit theorem. This all is in the problem. All right, you need to find n and x bar. What is m?
Amount of people in your sample.
Amount of people in your sample, and x bar? Good. X bar is the sample mean. I'm writing on the side that x bar is the sample mean and n is the sample size. All right. Next, you've got to find z sub c, which is the critical value. For this, you might need to draw a little bell curve. This is z sub c right here. And then use page, A16? Next step is to calculate the margin of error. formula is E equals Z sub C times sigma divided by the square root of n. Next is to create the confidence interval. It should look like a TIE fighter. In the middle, you've got X bar. On this side, you've got X bar plus the margin of error. And over here, you've got X bar minus the margin of error. And then finally, you need to make a conclusion. Which is one sentence. I am whatever percent confident that the population mean is between something and something. The book does not require you to write a sentence. I'm going to require you to write a sentence just so you get used to it for all of your free response questions on the AP test. Because that's always like, you could do all the math right, get a beautiful confidence interval, be done, and then they'd be like, you didn't write a conclusion, so it doesn't count. Does this help to have like directions like this? Yeah. All right. A college admission director wishes to estimate the mean age of all students currently enrolled. In a random sample of 20 students, the mean age is found to be 22.9 years from past studies. Standard deviation is known to be that. Population is normally distributed. All right. So we know the population standard deviation, and we know it's normal. Step 1, check. Step 2. Yep.
If it doesn't have that, then what do we do?
If it's not normal, or n is greater than or equal to 30, you say, I can't do a confidence interval unless I have more data. All right. Number 2, n is 20. X bar is what? Good, 22.9, sample mean. All right, next, Z sub C. It looks like we're trying to find a 90% confidence interval this time. Okay. I'm draw a little graph for myself. If 90% is in the middle, what percent is on each edge, each tail? 5%. So we're going to look up on A16, A17, 5% in the middle.
I've got 0.
What? You looking in the middle? This should be halfway between them, right?
Yeah.
This one's 1.645. Did you get that when you looked, Tristan? Okay. You good, Jocelyn? Riley, do you understand that?
Yeah.
Okay. By the way, the common ones are going to be 95, 90, 99, and 80. So you're going to see those a lot, and you're kind of going to get used to those Z sub C numbers because they never change. Also, they are listed right there. But also, let me be honest with you, they always love putting on an AP test at some point. They're like a 98% confidence or a 78, something that you don't have memorized. So you do have to know where it comes from, but this is a quick little fast thing. Okay. All right, so now we know our Z sub C right here. Number 4, calculate the margin of error. Z sub C 1.645 times sigma, which was 1.5 divided by the square root of n. Did you guys get 0.55? Okay. For number 5, I'm going to make my confidence interval.
Do you always take the positive on these ones?
Yes. What's the middle of your confidence interval of your TIE fighter?
What is it? 22.9.
Mm-hmm. And then I'm going to add and subtract 0.55. I'm also going to write age underneath this of students because that's what we're talking about. I'm labeling it. And then for number 6, I'm going to write I am what? 90% confident that the mean age of all college students is between 22.35 and 23.45. Were you just doing it for a fun?
Yeah. It's time for some.
Okay. I want you to try for tomorrow example 4, and that's all. That's your homework. Okay? Tomorrow my plan is to go over example 4 with you, to do the minimum sample size formula, which is very fast, and example 5. I think going over this answer and doing the bottom 2 will take us maybe 15 minutes tops, and then we'll spend the rest of the time going over multiple choice. On this one, you're going to have to first find x bar. How do you find x bar? Add them all and divide by how many you have. Okay? All right.